T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
15,
13,
12,
11,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff of NASA's Aqua spacecraft designed to study the Earth's water systems. And everything continues to go well.
Plus 30 seconds.
30 seconds into launch at this time.
Roger.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
Well, the first light images which we have gotten from the experiment of AIRS M2 HSP3 instruments flying together on Aqua indicate that our goal of achieving a very high accuracy of determining the temperature and the humidity in the atmosphere has been achieved. Has been achieved now to the extent that in the past we had thermometers flying on weather balloons. Now we can do the same thing from space. We do it day and night over oceans and over land with that accuracy that we always hope to be able to get over certain areas of the globe. Now we get it global. This capability now is unique to the USA. USA is the only country in the world having the capability of measuring the state of the atmosphere with perfect accuracy 24 hours a day, wherever it is, from pole to pole, from equator to pole, everywhere. Okay? Something that the weather prediction people have been dreaming about. And for the past 50 years, they have been relying on a small number of thermometers flying on weather balloon to get them what they want. Now they get it everywhere, anytime they want. When I refer to a thermometer in the sky, I'm referring to it symbolically, because with a thermometer you measure only temperature. But with a system like the AIRS system, you measure temperature, you measure humidity, you measure clouds, you measure a whole range of things, ocean surface temperature, all of them together. But to simplify things, I'm saying that it's like flying a thermometer, the thermometer for temperature. So what we are getting now, 700 kilometers up in the sky, we are getting the same accuracy as balloons that are launched from the surface and climbing slowly through the atmosphere. To be able to do this with the same accuracy is unprecedented. The significance of taking the oceans into consideration in our weather prediction can be illustrated in a simple way. 2/3 of the rain over land originates over oceans. You cannot make a weather prediction without taking the oceans into account. And you have to determine what's going on over the oceans. You have to make an assessment of what's going on over the oceans in order to be able to make a prediction of what's happening over land. The oceans' role, cannot really be minimized at all. We have to understand what's going on the atmosphere over the oceans with the same accuracy. We can determine what's happening over land. Putting the two together is going to be one of the major breakthroughs when we apply the AIRS data to improving weather prediction. Without exception, it has met and it has exceeded our expectations. You think of this experiment as something that is happening now, but it took us about 30 years to conceive of what should be done, how to do it, and we planned every step of the process from getting the instrument, to measuring the radiance, to extracting the data. And now we are finding out that all of our dreams, everything we wanted to do, has been accomplished. We get now from space measurements as accurate as thermometers flying on weather balloons. Something that will be of great benefit to those who are making weather prediction, especially those who would like to extend the range of our weather prediction from a couple of days to a week. There are two goals, for the AIRS experiment. The first one is collecting the global data on the state of the atmosphere in order to make improvement in our weather prediction. One such improvement would be to extend the range of useful weather forecasts from 3 days to 5 days. That by itself would be a great accomplishment. A second goal for us is to improve the ability to predict the track of severe storms. That is, we should be able with this system to determine the path of a hurricane 3 days in advance within 100 kilometers. If we can determine this, that would be a great accomplishment in terms of saving property, in terms of taking advantage of our a priori knowledge of where the storm will be heading and take the necessary precaution as the case may be. The first users of the data are going to be the U.S. Weather Service, the NOAA Weather Service, sometimes referred to as NCEP, the National Centers for Weather Prediction. What they are going to do is take the data now, which is global, very accurate, and begin to understand how to use it. They have used in the past data with the same accuracy, but it was so small. In today's system, we have about 4,000 weather balloon launched daily. With the AIRS system, we are going to be getting the equivalent of 400,000 such measurements every day. Right now, the data are made available to the numerical weather prediction centers, at NOAA, just to find out, how to use it. It will become operational. That is, it will enter the realm of improving weather prediction a year from now. It's roughly a year after AIRS, was turned on and we began to get the data. We go through a phase of validation, a phase through calibration, and a phase of learning how to use the data. And we hope, our goal is to show our product in a year from now. That is by June of 2003. The data which we are getting now is going to be used by many organizations. Mentioned NOAA as being the first user, the primary user of the data for improving weather prediction. But we have also 6 other weather prediction centers around the world, in Europe, in Canada, in South America, in Asia, and Australia. All of them are getting ready to make use of the data and to see how they can improve their regional as well as global weather prediction. International aspects for the AIRS experiment are very clear, very obvious, and one needs only to look at the acronym for one of the 3 instruments we are flying together. It's called the Humidity Sounder for Brazil, HSB. This is a microwave instrument developed by the Brazilian Space Agency and integrated within the remote sensing system on Aqua. So what we have here, we have our neighbors to the south who provided us with an instrument. They provided us with validation capabilities over the Amazon basin, and they are learning with us, how to use this wealth of information to make a better prediction, better assessment of the role of the Amazon basin in our weather and in our climate studies. We have also partners who use the data from Australia, from Italy, and from France. So it's an integrated international system in all aspects of the world. One of the measurements that Aqua makes, that AIRS makes on Aqua, is measurement of the water vapor distribution in the atmosphere. We measure also from this the precipitation rate. What we want to do with our data is understand the rate of evaporation and precipitation. It's a cycle, what we call it the hydrology cycle or the water cycle. Water evaporates, condenses, we got rain, and this takes about, it repeats itself every 12 days. What we want to find out is this cycle accelerating? Are we now heading into a period where the cycle will be done in 11 days or 13 days? But out of this, we want to be able to determine the quality and the abundance of our fresh water. We can make a prediction of where it is raining. We can determine how much fresh water, will be getting into our reservoirs, and this will help us plan in advance how to manage our water resources. It's another benefit, social benefit, that we are going to enjoy, after we begin to make use of the AIRS data. The rate of the hydrology cycle, whether it's accelerating or decelerating, is an open question. It has great implications because what it shows is where is it raining more and where it is evaporating more. As we will find out that in certain areas you are going to have more rain, but in other areas of the globe you are going to have more evaporation. So you are going to have certain regions with more drought and other regions with more flooding. And this is a very important area, for climate prediction, to determine what is happening to our climate as we add carbon dioxide, as it is changing, either by natural means or by the emission of carbon dioxide. The AIRS system, you can characterize it in many ways. One of them is that it is an information-rich system. It gives us information about the temperature, about the moisture, about the composition of the atmosphere, about the clouds, about the surface. One of the pieces of information that we are lucky to have on this system is an information about the distribution of carbon dioxide globally. Carbon dioxide is a main greenhouse gas. We put it out, when we are driving our cars, when you are burning fossil fuel. We want to know where it is spreading. We would like to find out as we go in a study to determine what are the sources, what are the sinks. Not all of the carbon dioxide which we put in space remains in space. Half of it is taken up by the soil, maybe by snow and ice, by polar regions. We want to begin a study that is very important for understanding the climate variability, and that is what are the sources and what are the sinks of carbon dioxide. From this we can determine how fast our accumulation of CO2 is happening and what are the sources. The benefits, the social benefits, commercial benefits which will accrue from such data are enormous. You cannot think of an activity which we undertake in our life which is not connected to weather. Transportation, okay. Surface transportation, air transportation is connected to weather. Agriculture is connected to weather. Our ability to predict what the temperature will be, when it will rain, how much it will rain, has enormous impact on the value of the crops, which we collect. So from this point of view, the impact is enormous, in addition to the ability to plan vacations, ability to have your team, to plan your soccer games, okay, way in advance. All of these things are going to have an impact on our daily life, on our individual daily life, as well as communal daily life. Okay.